Now we're going to start looking at conditional probability. So there's a formula. Let's copy that down. And that's read as the probability of A given B is the probability of A intersect B over the probability of B. So we're just going to write here how we say it. Probability of A given B. So it might be something like the probability of being good at volleyball given that you're over 6 foot tall. The probability of being good at chemistry if you're good at methods. So something that might have a relationship. We always use whatever is the second letter here goes on the bottom. So if I had the probability, I'm going to do D given C. So that would be D intersect C over the probability of C. So you sort of think there is a difference, do we say, are you good at volleyball given that you're over 6 foot tall is quite different that the probability that you're over 6 foot tall given that you're playing volleyball. So you just got to make sure the order is correct. So let's look at this one. We've got event A rolling a 6, so that's a 1/6. Event B is rolling an even number, so when we're going to dice, that's half of them that are even. What's the probability of rolling a 6? A, given that an even number was rolled. So it's A intersect B over the probability of B. So B is 1/2. The probability of A and B, so it's got to be rolling a 6 and it's even. Well, 6 is even, so we just end up putting 1/6 up here. So 1/6 divided by 1/2 is 1/6 times by 2 over 1, which is 1/3. And you do have to be able to do basic fractions, well, quite a bit of fractions in maths, particularly in probability. Let's have a look at the next one. In Stephen's class, 12 students study Chinese, 20 study French, and 8 study both. So I'm thinking this lends itself to a Venn diagram. I'm going to do Chinese. I'm going to do French. So what have we got? We've got, I always think start at the end, so get your last clue first, because 8 study both. So if 20 study French, only 12 study French only. And if 12 study Chinese, we've already got 8 of them, so we've got another 4 left. So let's answer our questions. Given that a student studies Chinese, what's the probability they also study French? So that's intersection over that last one. So that's 8 over, and Chinese was 12. Look, we don't need to do, if we did 8 out of 20 divided by 12 out of 20, it becomes 8 out of 20 times by 20 out of 12. And these cancel, and they always do. So when you do the probability of your French and Chinese, you can just do it as a whole number. And this second one is the other way around. It's Chinese given French. So the intersection is still the same, but on the bottom now we're going to have the probability of studying French, and there's 20 people that study French. You don't have to cancel down, but it's good maths to say that that's the same as 2 out of 5. So either of those answers are okay, but cancelled down is a bit better. All right, let's have a look at this next one. We've still got a couple more. 500 people questioned and classified according to age, whether or not they regularly use social media. So what are we looking at? A person is selected at random from these 500 people. Given that they're less than 25, so I'm going to go given that less than 25. So that's my second bit. What is the probability that they use social media? So I can do, I'm going to call that social media and less. So that's intersection over the probability that they're less than 25. So if we're looking for social media and less than 25, that's 200. And the probability that they're less than 20, sorry, that was, and probably less than 25 on their own is 240. You can leave it like that, or you can say it's 20 over 24, which is 10 over 12, which is 5 over 6. Any form, any fraction is fine. So that's like using a table. So basically we've done the examples of a Venn diagram, a table, and then the last one it's a two-step, so we're going to do a tree diagram. 55% of students are male, 45% are female. Of the male students, 13% say maths is their favourite subject. So I'm going to say, I don't want to use M for maths, and I don't want to use F for favourite, so I'm going to use P for preferred. So of the boys, maths is preferred for 0.13. So what's left is 0.87 is not preferred. For the girls, maths is preferred for 18% and not preferred for the remaining 82%. What's the probability that a student chose and prefers maths and is female? Look, I don't know, you just do enough of these and you get the hang of it, but mathematics and female would be female prefer. So I wouldn't do this one using a formula. I would say that this is just 0.45 times 0.18, which is 0.081. And that second pathway for the second question, a student chosen at random prefers mathematics and is male. Male prefers. So that would be 0.55 times 0.13, which is 0.0715. And you could write those as percents if you like, but I think that it's more sophisticated to write as a decimal. But either way, there's those answers. So one important thing is if you use the word and, we times. If we use the word or, we add. And if you stick with that, that's really handy. And is times, or is add. And then the last one, the law of total probability. I'm not a huge fan of that. I might have even... Oh, no, I haven't. That's all right. What do we say? If we want to find the probability of A, that can be A given B times B plus A given B dashed times probability of B dashed. I don't find a time when I have to actually use that formula. I figure things out, but if you work differently, that formula might be something that's handy to you. So let's look at this one. Using the example from the information for example 21. Yep. Construct a tree diagram. Done. And use it to determine... Okay, I've just realised what I did here. Oh, no. Probably the student selected is female and does not prefer mathematics. Look, I would just go female and does not prefer and just use the tree diagram, because if we do female and does not prefer, it's 0.45 times 0.82 is 0.369. The overall percentage who prefer mathematics, well, you've got the female and prefer, or you can be male and prefer. So this is where we use that or is plus. Sorry. But when we are and, like this previous one, female and don't prefer, we multiply. So female and prefer, we worked that out in the previous question here. That's the male and prefer. So that's the second one, which was 0.0715. Female and prefer was this one, Hang on, just saving. Female and prefer was this one, which was 0.081. And if you add those together, it's 0.1525. It's certainly a long video, isn't it? In a certain town, the probability that it rains on a Monday is 0.21, and it rains on a Monday, the probability it rains on Tuesday is 0.83. So what I'm going to do for this tree diagram is I'm going to make this Monday, and it can rain or it cannot rain. This is Monday. What happens on Tuesday is it can rain or not rain. So sometimes it can be confusing what's going to go on your arms of your tree diagram. So in this case, we're talking about the first day is Monday, second day is Tuesday. Let's see what we've been told. Rains on Monday is 0.21. So this is 0.79. If it rains on Monday, the probability it rains on Tuesday is 0.83. So it goes there, and then we can have 0.17. If it does not rain on Monday, then rain on Tuesday is 0.3. So not rain, rain. And now we have that set up. It's not too hard to answer the questions, but that tree diagram, once you see it, it's easy, but doing it yourself can be tricky. What's the probability it rains both Monday, Tuesday? Rain followed by rain. 0.21 and 0.83. What's the probability it rains on Tuesday? Well, it can be this one, because it rains on Tuesday, or it can be this one, because it rains on Tuesday. So we have 0.1743, we found that out from A. So that's one scenario, or it can be this not rain, rain, which was 0.79 times 0.3. And if we work those out, 0.4113. So the way to get good at this is to practice the questions and make sure you finish those off over the holidays.